Let's look at the seventh proposition of book 3 of Euclid's Elements. It's quite a big description of the proposition. So let me break it down for you. Given a circle, if we have a line passing through the center, that would be the diameter, right? AD will be the diameter. What the proposition says is that if we take a point F on the diameter on any one side of the diameter, then if we take up any points, let's say B, C and G, and if we join F, B, F, C and F, G, then BF would be smaller than AF, CF will be smaller than BF, GF will be smaller than CF. So what it boils down to is that the distance from F to any point on the circle depends on the particular location of that point. The farther away it is, the longer the distance. So G is nearest, C is farther, B is much farther and A is much farther than B. And the proposition also says that there is no other point on the circle which will have the same distance from F other than a point on the opposite side of the diameter. So there will be one more point here which will be equal to FG. There will be no other point. So that is the proposition. Please go through the description of the proposition and try to relate it to what I have described here. Now, to be able to prove all this, let's join EB, EC and EG from the center to those points. Let's take it step by step. We know in any given triangle, the sum of any two sides is greater than the third side. So EB plus EF is going to be greater than BF, but EB is equal to AE. So if we substitute that, we will end up with AE plus EF is greater than BF, which means AF is greater than BF. And now let's look at BE and EF, this triangle, BEF triangle, and ECF. Now here, EB is equal to EC, radii of the same circle. EF is common to both, so they are equal. But this angle, angle BEF, is greater than angle CEF. And we know that the side opposite to the greater angle subtends the greater side. So that means BF is greater than CF. And again, with respect to G also, we can use the same logic. CE is equal to GE. EF is the common base, but this angle is greater than this angle. Angle CEF is greater than GEF. So which means that this side, the side opposite to the greater angle, is the greatest. So that means this CF is greater than GF. So we have shown that AF is the greatest, BF is smaller than AF, CF is smaller than BF, GF is smaller than CF. Or we can say it, in the other way around using greater than. So that was the first part of the proposition. The second part talks of there being only one other point on the opposite side of the diameter. Now for that, we will have to make sure that we copy the appropriate angle on this side. And we know how to copy an angle. So let's copy the angle. Now, a circle of radius EG at E is already there. Yes. So we draw this circle, we take the intersection and we join those two. So now this angle is equal to this angle. Okay, so let's join the points. Let's name this as H and let's join HF, right? Now EH is equal to EG, radii of the same circle. EF is common to both the triangles. And we have copied this angle here. So angle FEG is equal to HEF. Side angle side. That means these two triangles are congruent. Since they are congruent, that means all the corresponding sides are also equal. That means HF and FG are equal. We have to show that this is the only point which is equidistant from F apart from G. So let's assume the opposite. Let's say we have a point K which is equidistant from F where Fk is equal to Fg. Okay, so let's join these 2 points. Let's join these 2 points. Now here if you notice that Kf is equal to Fg because this is assumed to be equidistant from F. But then HF is also equal to Fg. That means Kf is equal to HF. But this point is farther away from F on the circle when compared to the distance to H from F. And a point which is farther away on the circle from a point on the diameter is going to be longer. So that means we have reached a contradiction. That means our assumption that this is at the same distance as G from F is wrong. That means this point is not possible. So that shows that there is only one other point apart from G which will have the same distance from F as G is. So that is proposition 7 of Euclid's book 3 of elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions. Please feel free to download it, refer to it, share it if you feel somebody else will find it useful. And most importantly, if you find any mistakes, please don't hesitate to put it in the comments. I will rectify it in the book, and the link to download the latest book, latest version is available in the title page itself. That's it for now.